traditional law. I was asked to teach a course about a year and a half ago at our local University of Wisconsin here and on earth resources and sustainability. And it's become kind of traditional on college campuses these days to acknowledge that we're occupying lands of indigenous folks. A lot of the energy transition talk is just about fossil fuel. And one of the things that I've, for a couple of decades, tried to give the pitch on is that we need to look at all resources because it's going to take probably all of them to get through the next few decades. And so I'd like to talk about those a bit. And I'll talk about primary energy consumption, CO2 emissions, and alternative energy technologies and critical minerals that are necessary for alternative energy technologies, particularly. So world energy consumption, as we all know, has been going up. There's about a 3.3 times increase over the last 56 years. Many of these charts that I'm going to show go from 1965 to 2021. And for, I call the big three, China, India, and the United States, because they're the three most populous countries in the world, and they've been consuming minerals at a pretty rapid pace, particularly the United States and China, and India is just getting started. So in terms of consumption of energy, there's a line here for comparison of 100 exajoules, and we've stayed just kind of under that, and we've pretty well flattened off in terms of our overall primary energy consumption, whereas China has broken through that 100 exajoules at a rapid pace. And India really hasn't gotten started yet. And just to compare, although all three of these countries are almost 50% of the world's energy consumption. A little bit scary thing is that if we put India up to China today, and they're on the same scale, India is only where China was 25 years ago. So if India gets cranking, and they certainly want to, and they're working toward that, there's going to be a tremendous consumption of energy in India. And most of that is being done with coal. They built a new coal port that could bring in coal. And so I don't think they can really go at the pace that China was going because they're a democracy rather than a communist country, but they will certainly increase their consumption. And as that consumption has gone up, that dashed line is the line from the previous chart, this dashed line, the 2 ago. And the CO2 emissions have gone up likewise. We've had a 2.5 times increase in CO2 emissions in those times. And North America here, Europe here, but the big increase in CO2 emissions is in Asia Pacific. And population has gone up during that period of time. And we've had about a 2.4 times increase in population since 1965. So here's our energy consumption, 3.3 times increase. And here's the population laid on it at 2.4. So not only has consumption increased relative to population, but the per capita has also increased. And to me, world population is our existential crisis today. I looked at this, I almost wrote a book on it one time. I think all of the ills that we have in society today can be traced right back to this. And John gave us a good talk on this at the end of February. That course that I was telling you I was teaching a year and a half ago, we watched the world odometer turn 8 billion. And that was 13 years ahead of where it was supposed to turn to 8 billion, which was 2035. And this it's 100 million people added to the planet in a year and a half. And who's feeding them? Who's educating them? Who's housing them? Who's providing them energy? I mean, this is just an unbelievable situation that we're in, and we're way overshot on this, as John pointed out in February. When I was born, there were 2.5 billion people on the planet. It's pretty frightening to have lived to see this. Okay, so we have this new idea about we're going to use electric vehicles and solve all our problems, except that it's not really a new idea. And I'd like to talk a little bit about what actually is involved with these electrical vehicles. That's BEV is a battery electric vehicle. What is this thing doing? It's plugged into this green thing over here, which is just a glorified outlet for electricity. And you have to get electricity to it somehow in order to charge the battery. But what's really going on at this charging station? And what's going on is that it's pushing lithium ions from the cathode of the electric vehicle's battery to its anode, charging the battery. So this is a simplified diagram. Hopefully it's simplified, and we can make it simplified here. The cathode has these lithium ions on it, particularly when it's discharged. Virtually all of them in the battery are there, and those are these turquoise things in here. So when we charge like that vehicle is doing, what we're doing is we're driving those lithium's ions back over to the anode. And when they're all back over there, the car is said to be fully charged and ready to take off. And when it's discharging, when you're using the electricity that you can get from that battery, and remember that batteries are not primary energy sources, they're just storage, you're driving, the lithium is moving back over to the cathode. And so you go through that cycle over and over. So why do we care about lithium? Well, we import about a quarter of the stuff that we use, and we're continually increasing our imports of all of these minerals that are used in alternative energies, and the price has gone up pretty dramatic. It's people who look at financial things would call this volatility in price, from $7 to $84 per kilogram. And it's dropped back now. It's still double what it was back in 2020. So these prices of all these commodities are just gone wild through the last couple of decades that we've been involved in this transition. Okay, and so let's look at the anodes. The lithium goes from the cathode to the anode and back and forth. And the anode in this battery, and most batteries in cars, are graphite layers that attract the lithium and release it to the cathode. And graphite has nearly doubled in price over this period of time. And we import 100% of it. And where do we get it? Well, we get it in a number of different places. Madagascar is one of the biggest reserves in the world, and it supplies other people. And we don't really know whether we're getting Madagascar or not, but this is some of the, Madagascar is known for its artisan mining of various mineral resources, such as these teenage kids who are down 200 feet underground, getting stuff by hand. So the cathode, we know that the anode is graphite. The cathode can be made of a number of different things that the lithium is attracted to get that. So we have a number of metals that create that, and it might be cobalt, nickel, or manganese, or some combination of that, and some iron. So nickel also has been very volatile, up and down, increasing 10 times in price there, back down for a while, but back up in the 2022, and we import over half of what we use there. Cobalt, kind of the same thing, high volatility, and increasing as much as 4 times in price in a short period of time, then dropping back and increasing back again. And we import 3/4 of the cobalt that we use. And cobalt, this is what a specimen of rock containing cobalt looks like. And most of that is coming from the Democratic Republic of Congo and Katanga. And Democratic Republic of Congo, you've heard about blood diamonds in Africa. they're now talking about blood cobalt mining in Africa. So we get this stuff from places that aren't very well in terms of safety and health of the people who get it out. Manganese price, again, is volatile like the others, and we import 100% of the manganese that we use. So it's kind of interesting in terms of weight. A lithium iron phosphate battery, this is in pounds, and the cathode material is 300 and some pounds, graphite's 160 pounds. So the total of just the battery of a car is about 2,000 pounds or a ton. We talk about half-ton pickups and 1-ton pickups, and your electric vehicle is going to be a 2-ton vehicle. And this is just by comparison of the motor is 100 to 200 pounds, depending on which type of Tesla that you're getting, whether you want the real high-powered one that goes from 0 to 60 in 2 seconds, or whether one of the lower ones that you're trying to do. By comparison, the ICE or internal combustion engine, 10 gallons of gasoline weighs 60 pounds, and 4-cylinder, 6-cylinder V8, you can get up as much as 700 pounds there. So your max, if you'd be carrying 10 pounds of gasoline, might be 760 pounds compared to the 2,200 pounds of the BEV. And we use a lot of rare earths in here. This is one from the Toyota Prius back in the day, and it has rare earths in a lot of components, primarily in the motor and the generator, where you have neodymium, praseodymium, and dysprosium. These are important because they're really strong magnets, but they're also magnets that retain their magnetism at high temperatures, which common ordinary magnets lose their magnetism when you get the temperature very high. So a lot of rare earths used in all of these things, and neodymium, which is one of them. There's the price of that, and you can see that it spiked up. Before this chart started back in 2009 to 2011, you can't believe the jacking up of the prices and the games that the Chinese were playing with the rare earths, since they are the major supplier of rare earths in the world. So significant increase in the 2020s of about 4 times. And we have to import over 90%. We've gotten one mine opened back up, and that's a California Mountain Pass rare earth mine, which I visited in the 70s when it was operating, and it went inactive for a long period of time, and then it's come back on now. But guess where the neodymium sent to be processed? Sent to China. And electric vehicles have really taken off in 2020s, a pretty steep curve of increase beginning about 2020, and it continues to increase. This is US. And these electric cars require about 6 times the mineral inputs of a conventional car. We'll look at more of that. Well, this is through 2022 and 2023, we got up to 1.1 billion cars that were sold in the United States. But you can see that doesn't even come close to what China is doing in electric vehicles. And it's the 8th year in a row that they're the leader of EV sales. So these are the greenhouse gas. Somebody got a message from somebody there. Life cycle greenhouse gas emissions compared for a BEV on the 2 on the left and an internal combustion on the right. It is of kind of interest that you've got quite a range of variation there on the electric vehicles. So, electricity consumption. Electricity is not a primary energy source. Primary energy sources are used to create electricity. and electricity is a form of energy, but it's made in other ways, and then it's transported and used to do work. So it's been increasing at a fairly constant rate with time. And so back to our picture here, where do we get that electricity that's going to charge that battery? And of course, the ideal is to have a solar array right nearby that can have a very short connection to your charging station or the outlet, and can charge your electric vehicle. And it's pretty low greenhouse gas emission if you have that sort of situation. Or my Hy-Vee here in town has little wind turbines on poles right next to where their charging stations are, which I think is pretty cool. So the source is important, obviously, if we're going to cut down on greenhouse gas emissions by doing this. So where do we get electricity? Well, the fundamental part of where most electricity is developed is that we have magnets that we put opposing polarization on these two magnets, and that creates a magnetic field. And within that magnetic field, then we put a copper coil or loop called an armature, and we rotate that somehow. When I was a kid, I wound the little thing myself, and we had a magnet set up, and I had a little crank, and I just cranked that thing around as fast as I could. It was connected to a little light bulb, and the light bulb would start to glow. Never got much beyond a glow. It certainly didn't get to where the outlet gives to it, but it was fun to do. And unfortunately, I don't think many kids these days do this sort of thing, and therefore they have no idea where electricity comes from other than two holes in the wall. So we create alternating current that way. If we change these slip rings on the back, we can get DC out of it also. So where do we get this electricity? Well, we've got these mechanical electricity generators. It's where we get most of it. So what's happening to generate that electricity is you're turning copper coils. There are all kinds of different designs for these copper coils, but it's all just as simple as that little diagram that I showed to begin with. And we've got turbines that do the cranking rather than your little hand doing the cranking. You've got turbines that turn these copper coils within the magnetic field to generate the electricity. And fluids drive those turbines. That's the primary energy, creates the fluids that will drive, or the fluids themselves may be the primary energy. So wind is one primary source that turns those, and it does it through those big propellers on them. And water is another one. Norway, 100% of their electricity is generated through water turning the turbines that turns that little copper coil within the magnets to create it. But steam's the one that most of the places around the globe use, and they use fossil fuels to create the steam, or wood, nuclear, or geothermal. Fossil thermal is a big user of that, and fossil thermal plants have been increasing fairly steadily through the last 40 or 50 years. Looks like maybe they're flattened the last couple of years. We'll see, but would be nice if it had. So instead of those, what we're trying to get to is something like this, where we've got solar that the sun energy from the sun, the energy from the sun creates a photovoltaic reaction in here and creates electricity, or the wind turns the turbines. So the world's been increasing its consumption of renewable energy quite substantially, and is on a pretty steep curve of increasing the amount of renewable energy that we have available and use. And most of that's occurred since 2010. I'm going to use that as a marker because 2010 is kind of a turning point for when renewable energies and other things associated with it took off. And in terms of our big three countries of China, India, and the US, China is the leader in renewables. It's interesting. I was really kind of shocked when I heard Amory Loving tell me that China was the leader in the world in renewables. This was like 12 years ago. I thought, my gosh, I didn't know that. And they certainly are. And they've been doing a lot in renewable energy, much more than what the United States has been doing or Europe. And orange there is India. So these three countries are more than half of the world's renewable capacity, thanks mostly to China. And wind's been around a long time to serve us in various ways, most commonly used on ranches and farms to raise water. But now we've started using it to turn these large turbines and generate electricity. And the world has been increasing fairly consistently since 2010 and actually steepening in the 2020s or just before the 2020s and generating more and more wind capacity. And these next two slides are just from a talk that I used to give in 2007. I think Dave Bowden, who's on here, was there at this particular talk at the Association for the Study of Peak Oil. And back at that time, the Department of Energy said that the US goal was to generate at least 80 gigawatts of wind by 2020. Well, we're here, so we can see how that worked out. And that was going to require, in order to do that, over 500 million tons of copper, because there's a lot of copper in these wind turbines. Okay, so this was our goal that we wanted to reach back in 2007, and here's where we were in 2010, and we did pretty darn well. We actually exceeded it by about 50%, and so we got there, we made it, and I think that's admirable. China, at the same time, they said that they wanted to have 4 times what we did by 2020. They wanted to have 330 instead of 80 gigawatts by 2020. And so they started out on that. And this is at one of their summits. You know, China has these 5-year plans. And the thing is that they tend to make these 5-year plans. They're pretty darn good at it. So they didn't make it, though. Instead of reaching 330, they reached 329, and they only did it by 2021. They didn't reach it by 2020. So day late and a dollar short. That took about 2.5 billion tons of copper to achieve that. Okay, so we've been increasing, the world has been increasing solar and wind, and solar is shown in the turquoise color, and wind is shown in the turquoise color, and solar in purple, and it's really pretty cool. And in 21, we actually achieved more electricity from solar than we have from wind. And when we put the two of those together, they're pretty impressive growth from 2010 on, and we have gone from about 0.5 terawatt to 1.6 terawatts. So in this short period of time, we've increased it by more than 3 times. And of course, it's interesting, this is from the International Energy Agency, which we'll talk a lot more about in a minute, that there's more use for the unit of power that is generated. It's taken 50% more minerals for each new unit of power because of renewables. And this is our wind power capacity by folks, and the purple is China, the turquoise is the world, and Europe is the orange, and the US is yellow. So China has 40% of the world's wind capacity in 2021. And 40% more than all of Europe, and 2.5 times all of the United States. So they really have gone after it and been successful. In fact, they shut down some power plants, coal power plants, because they were trying to actually do a better job of generating polluting electricity. But they found that they couldn't achieve the economic growth that they wanted. And so in 2017, they started back up with the coal plants again. Well, this half the world's emissions in 2020. This is China in over a 5 or 6 year period compared to the rest of the world. And the rest of the world didn't do nearly as good as China. In 2020, if we compare those, we find that Europe was way lower and the US was way lower. I mean, they really are the stars in terms of renewable energy, but they don't get much credit for that because most people don't even know about it. Let's look at this world electricity generation and kind of put things in perspective. We, from this 20-year period from 1985 to 2007, we increased our electric usage a lot. The world did. So in just 20 years, we doubled our consumption of electricity. And that continued. And on a pretty much straight line, it continued into the 2020s. Now, this 2010, remember, was the time where renewables really took off, where solar and wind did such a fantastic job of increasing their ability to generate electricity. So let's look at that period from 2010 to 2020 in terms of consumption. What we did up there is that we increased electric consumption by this amount in that period of time, just a little over 10 years. So there's that amount of increase, and that amount of increase is 6.6 terawatts. So remember what we had from wind and solar. Even with all of the great results that we had, that is not even a quarter of what the increase in use of electricity was around the world. So I started this with the steep hill to climb. I think that you can see from this, it is a huge mountain to climb. We're not beginning to change this electricity from coal to wind and solar. We're not even keeping pace with the increase in usage of electricity, not even coming close. So we've got a lot to do to make a transition just in the world of electricity. And a lot of people still don't have access to electricity. Almost 1 billion people don't even have access to electricity. And a lot of them want that access. And when they get it, they're going to start using it. This shows the area where most of that lack of access exists, which is referred to commonly as energy poverty. So I'd like to take a look at some of these other minerals that are available in or used in alternative energy. And solar, if you're going to have solar, you need these elements and critical minerals to give you those elements. If you're going to do electric vehicles, we've seen those except for tantalum and vanadium already. And if you're going to do wind, you're going to need rare earth, and there's overlap between the 3 different areas. But central to all of this is copper. So I want to take a look at copper and what's happening in the world of copper relative to its growing usage. So a Tesla takes more than twice as much copper as conventional cars. This is a 3 megawatt wind turbine, which is kind of common for onshore wind turbines these days. Each of these turbines requires 22.5 tons of copper. A lot of copper going into this. As we saw the numbers for China and the US to reach their goals by 2020. Well, the price of copper has gone up quite a bit. And today it's 6 times what it was back in the early turn of the 21st century. These are the top 5 producing countries. Chile is the best. I mean, best. Chile produces most. Peru is second, and Peru just had a deal where the Inter-American Court of Rights ruled that this country, big polluter, which is an American company, Doe Run, is going to have to pay some reparations for the damage that they've done. China is next, the ERC, and then us. A lot of people, very knowledgeable people in a lot of areas, don't realize that we're still producing a lot of copper here, 6%. But we still have to import nearly half of the copper that we use. And as important it is as it is in all of these alternative energies, that import is an important factor. Okay, so our mines only produce 55% of what we consume. Now, here's one of the things that's happened is that at the turn of the 20th century, the average grade of U.S. copper ore was about 2.5%. So 97.5% of the rock that you did as you mined was waste. So you had to move an incredible amount of rock to get that copper out. Today, we're not even over 1%. We are 0.3% of all the rock that you mine is copper. And so that requires that for the copper for one 3-megawatt wind turbine, you're going to have to move 5,600 tons of ore, which is a lot of pounds. And this is one of the huge copper mines in Arizona that I just happened onto one day, and I couldn't believe my eyes at the scale of it. I'd never even heard of it before. But this is from this point right here to over there, that's 5 miles. This thing is just absolutely immense. And so copper only comprises about 1% of a wind turbine. And you can see how much of it there is. Steel has got to be mined. Fiberglass and resin, that's a petroleum product. So if you eliminate all fossil fuels, you're not going to be able to create the secondary things of fiberglass, resin, or plastic. And iron and cast iron, of course, you're going to have to mine, as are aluminum. So it takes 9 times more mineral resources in a wind turbine farm than you would have to have in an equivalent gas-fired power plant. And of course, we're moving offshore, and there are advantages to doing this, but there are also disadvantages. A couple of the companies that were operating offshore United States just backed out of their commitments to build. So this shows the world electricity production by source, the fossil thermal we saw before, nuclear and hydro, and then other renewables, which are wind, solar, and minor amount of geothermal contribution there. And this is showing what it was in 2019, where the various things were coming from. And coal was still the big source of generating electric power, and natural gas had been increasing quite a bit. So in terms of world primary energy consumption, oil is the biggest in the world at 29.5. Coal is next, natural gas is next. So 80% of the primary energy in the world is from fossil fuels. That's a steep, steep hill to climb to replace all of that. And I think there are things that we're working on to make things more efficient. Natural gas has become more efficient and is putting out less greenhouse gas per amount of gas burned. Nuclear is about 5%, and there's a big effort to grow that. In case you didn't know it, we're the largest generator of nuclear power in the world by far, more than double the number two. And most people think it's France because 70% of their electricity is generated by nuclear, but they're a tiny country compared to us. We're the third largest country in the world. And hydro is about half of what the nuclear is. And the renewables usually include hydro, and biomass is an interesting one, which is 15% renewables. Biomass is 2/3 of what we categorize as the world's renewable energy. Wind and solar are only 2.5% of the world's consumption of primary energy. So in terms of emissions, this is that Asia Pacific bulge that we saw before, and their increase in CO2 emissions is huge compared to any other part of the world. And China, of course, is the big one. India is second, and Japan is third, with the other countries kind of filled in there. And China passed us in CO2 emissions back just shortly into the 21st century and is way ahead of us now. They're more than double what we are. But we should be a little cautious of being smug about that. We have been decreasing our emissions with time, and it's a pretty steady downward decrease. And we've accomplished that in two different ways. Reducing coal-fired power plants was about 1/3 of it, and natural gas conversion, converting this coal to wind. And natural gas is the rest of the way that we did it, converting coal into natural gas. So 2/3 of the decrease is that switch from coal to natural gas. But if we get smug about it, we've exported most of our manufacturing to China, and so we shouldn't get too down on them for what they're putting out, because they're supplying the world with material goods, and we use a lot of those material goods, and most of us are pretty dependent on a lot of the goods that come from China. I'm going to talk a little bit about some studies that the International Energy Agency did. This is a group that was set up by these member companies listed there, and then they're shown in the map. This was set up decades ago in order to provide reliable energy information to these countries, supposedly unbiased and reliable. And I think they do a really good job of this. Now, this is different than the Energy Information Agency, EIA, which is it's under the Department of Energy of the United States government. This is a much bigger and probably much more respected group of folks. And there are associate companies with that. So the IEA did recently a study. Now, I'm a great skeptic of virtually all forecasts of all kinds. I used to have a hobby of keeping forecasts and seeing how wrong they are when the time comes for what they're being forecast for. And I can tell you that most things don't come true, and a lot of them miss by huge marks. But the IEA is not doing a forecast, but what they're doing is saying, if you reach a certain thing, it's going to take so much solar, so much wind, so much EVs, and that will require so many minerals. So they ran 3 scenarios here to find out how, if you achieve what you say you want to do by 2050, you're going to need this much critical minerals to do that. And so the first one is a sustainable development scenario. And that was a scenario where if people meet the goals that they agreed to at the Paris Agreement, then this is what it's going to take to do that. And the second one was, what if China and all these countries that didn't sign on to the Paris Agreement suddenly, for some reason, said, hey, we want to be a part of this, we want to get on, and we want to do what we need to do to get to net zero globally by 2050. So that was a second scenario that they ran. And then the third was to take the goals that each country said they're going to achieve and look at what that looks like. Okay, so one of the things that they concluded is that the total demand from these clean energy technologies, it's going to require that over the next 2 decades, that over 40% of the copper mined in the world will be used in these energy technologies. So all the stuff that it's being used for right now is going to have real competition from this area. And the rare earth elements, you can see also 40%, 60 to 70% of the production of these minerals, or that give you the elements, is going to go toward the clean energy technologies, and almost 90% for lithium. So EVs and battery storage already displace consumer electronics to become the largest consumer of lithium. Okay, so these are all the kinds of things that they did, the studies that they went through, and you can see on the right side all of the elements that they looked at and what technologies they were used in. On the left side are all the different kinds of things, and they'll tell you what are used in this, and I'm not going to try to run through that here, but they looked at all of this sort of thing. And so what they concluded was that under the these are the things that the growth is going to occur in, and electricity networks is the dark orange, and they're going to have to increase 6 times over 2020 benchmark. And the EVs and battery storage, the darker yellow color, is going to have to increase 4 times under the SDS and 6 times under the net zero by 2040. So if you're going to reach net zero by 2050, you got to have all this done by 2040 in order to achieve it by 2050. And this shows the growth in percent of the market that each, or the percent relative to 2020 of growth. So lithium relative to 2020 is the index of 1, has to increase its production 42 times over what's being produced in 2020. Graphite 5, cobalt, nickel, and rare earths. I mean, these are huge, huge requirements. And I don't think, frankly, you can come close to achieving them. This was another part of that study, and you can download this study for free from the International Energy Agency, or I can actually send you a PDF of it if anybody's particularly interested. Just let me know. So this just shows the different, so for like lithium, here's the steps, what people have, the path that people are actually on and said they have committed to. And this is the achievement. If you're going to get to net zero by 2050, this is what it's going to take of each of these things down here. And that's done for each one of these cobalt, nickel, copper, and rare earths. And this is kind of interesting that the deployment of annually of solar PV has got to triple by 2040 over what it is in 2020, and in order to achieve these goals. So it's a big, big lift. And where are these things all coming from? This shows the source of where you're going to get them. And remember that the extraction, we get rare earths from China. The extraction is pretty well scattered around the world in terms of where we get it, but you still got to process it. And China does all the processing of these things. So we mine stuff here in the United States, send it to China to process, and then buy it back from them. It's a pretty crazy situation that we've got going on. And these are the greenhouse gas emission intensities for production of some of these various things. And it's interesting that the light purple is the greenhouse gases from processing, and the dark is the part from mining. So both of those have to be considered when you're doing full-scale cycle, life cycle of various technologies. So what the International Energy Agency required in 3 short things was that if you're going to meet the goals of the Paris Agreement by the people who agreed to it, you're going to have to quadruple these mineral requirements by 2040. To meet net zero globally by 2050, if China and everybody else decided to get on board, you got to have 6 times by 2040 of what you're doing in 2020. And in their report, they say there isn't time to fool around. In order to have any chance of doing this, you've got to get started now, not 5 years from now, not 10 years from now. And one of the things that they did conclude is that the policies that the countries around the world have stated that they're going to follow to get to the Paris agreements, they don't add up to the Paris goals. So this was one of their statements from their report, that today's mineral supply and investment plans fall short of what is needed to transform the energy sector. I just want to close with this. I went to my 62nd high school reunion last August, a year ago. And when my wife and I were driving back from Pittsburgh to our home in Wisconsin, as soon as we hit Ohio, we started seeing soybean fields and corn fields and soybean fields and corn fields. And we drove through Illinois, and we drove through Indiana, and we drove up through Illinois, and it was just one after another: soybean corn, soybean corn, soybean corn, soybean corn, as far as the eye could see. I just had to pull over and take a shot. This one happens to have some wind turbines in the background for scale. Way too much of this is going to biofuels, and this is one of the worst things that's happened in the United States, one of the biggest scams. I know of 3 states whose Department of Natural Resources have documented in writing in publications how damaging all of these biofuels are to the environment, from the consumption of water to destruction of habitat and on and on. And we had 75 plants doing biodiesel, and you can see the capacity of that. So biofuels has been increasing through time and probably will continue to increase because there are huge subsidies to big ag, and those aren't going away. And renewable diesel capacity has been increasing, and soybean oil per year. So, at any rate, close with this little sign. This is not me, Vince. This is another Vince somewhere, which I haven't met, but I'd love to meet him because he's got great signs, I think. And so, thanks for your attention in this steep climb. I think you perhaps have some feel for how steep a climb this might be.
Well, thanks, Vince. And that's a steep climb indeed. All the graphs are saying ×4, ×6, times X in order to get us where we want to be. Rob is the first one with a hand up. Go ahead, Rob, unmute and go ahead.
Oh, that wasn't the question. I thought I was picking an emoji that was clapping hands. Thanks, Vince.
Thank you.
Okay, Dean, you have a hand emoji.
Yeah, that's just a single hand, not a clap. So, yeah, thanks, Vince. This is really well done, concise kind of show of our situation, I guess. Couple quick questions. Uh, I think currently today, doesn't the world use isn't about 20% of the energy use electricity? And if we're going to get to that one of those net zero targets, how much electricity would we end up with? I mean, we wouldn't be getting rid of
Well,
all fossil fuel, right?
well, remember that electricity is not primary energy.
Correct.
We use
Yeah.
primary energy to generate electricity. So from a comparison of terawatts, I don't have that. I could get that, but I haven't actually calculated that.
Okay. So, I mean, I haven't looked at those targets either, so I don't know what that, like how much fossil fuel energy does that cut out? But well, a second question then, maybe you know the answer to this one. So with these targets and that amount of mineral usage, is that strictly to cover, say, the first iteration of solar and wind and EVs, and that we would need significantly more for replacement in a lot of these devices?
Yeah, I just don't understand how we could possibly fully replace our electrical consumption. I mean,
Yeah.
just to do that was my reminder to shut up. It's set for close to noon, 5-minute warning. I don't see how it can be done. I mean, think about it. People have tried to open a new mine in Colorado for 30 years and finally gave up fairly recently. There is no reception that I'm aware of in Colorado to a new mine. The only reason that the molybdenum mines are going is because they were open long ago, and when they went inactive in the early 80s, they kept their permits alive and it's a lot easier to start up than to start from scratch. I mean, if you try to start from scratch, it's not going to happen. The same thing with the rare earth mine in California. It was only able to get producing rare earths in here because it had a permit and it was just on standby. And the same thing with Cripple Creek. Cripple Creek could never start up for gold in the magnitude that it's got now. I mean, you have such incredible opposition. The opposition has gotten very sophisticated in the last half century about how to stop these things, because the permit process in itself is very long. But the problem that I see, and I was in Colorado state government and worked very closely, actually was part of the minerals thing. The permitting process is not the problem in Colorado. The lawsuits are the problem. That's what stops these things. The minute a permit's granted, the lawsuits just fly. And so it's more money for lawyers and more, and they know how to do this. They know how to stop projects. So you're not going to get a mine in Colorado. You're not going to get one in California. You can get one maybe in Nevada, although that's changing. It's not going to happen. So we're going to sit here saying we want all these electric vehicles, but we don't want the mining.
Yeah.
Let's do that over in Africa. That's where we want them.
One quick follow-up to that, if I may.
Sure.
So even if we did get approval, what's the lead time to actually commission a mine? I guess
Well, there you
a
are.
little
Like
bit.
it's at least 10 years,
Yeah.
and mines, they're using electric trucks now because they're great. They're very powerful, and they can generate the electricity right there on site, although most of their generation is probably from coal or something like natural gas probably now.
Dave, go ahead.
Thanks, Phil. Vince, thank you for a terrific presentation. Very informative, and I think pretty sobering to those of us who are looking for solutions. I have two questions. The first one is, I noted that you did not you didn't present too much about photovoltaics. You talked a lot about copper and the amount of copper that's needed in wind turbines, that's needed in electric cars, that's needed in electric power infrastructure. But when you look at photovoltaics, obviously they require the rare earth minerals. But once those are manufactured, you don't need to worry about the turbines. If you do distributed energy in terms of putting it on people's homes, instead of attaching it to larger power grids, you avoid the use of copper. So I was curious about that. And then the last question is going to be the hardest, and that is, so after presenting all of your information, what do we do now?
Okay.
Electrification and renewable energy versus fossil fuels.
The solar, I think the most important thing that I said there was to point out that solar passed wind in 2021 as a renewable source. I personally think that distributed solar is going to be a real boon to helping us through, well, that's the right word, but it's going to be a boon to helping us get to more alternative energies. The big solar farms, though, I'm not a particular fan of because I've read too much about the damage that's being done to the environment, and people don't really like that kind of area being covered by them, even if they're in remote areas. And so, but I think the distributed solar, where people are covering parking lots in hot areas and putting solar panels up on the covers, just makes incredible sense. One of the most brilliant things I've seen Californians done, and I got my PhD in California, so I've got a warm spot in my heart for what's going on out there. Hi, Maury, I just saw you there. Good to see you, and thanks, Dave, for that. One of the things that I saw in California was they have these canals. You know, the Southern Californians steal water from the Northern Californians in order to supply all the growth in population. And those canals were uncovered when I was out there. And now they cover them and put solar panels on them. So they are using space properly and for a dual purpose there to hopefully reduce the evaporation and generate some electricity at the same time. So there are a lot of these things. It takes creative people to figure them out. And I see lots of things that I think creative people are doing, but I'm like Maury on carbon capture and sequestration. I was involved very early on at the turn of the 21st century in carbon. We were a member of the Southwest Coalition for Carbon Sequestration, and we had a big project up in Northwest Colorado to look at the potential for that. And we spent, our original project was supposed to be $6 million. And we had gotten contributions from private industry, and we had a DOE grant for $3 million. And so this was one of the shovel-ready projects you may remember from 2008, which was a big scam. There was nothing shovel-ready for, 90% of the stuff. But the money was appropriated and it had to be panded out. So we got money to do this experiment, which probably never should have been done. And I got a call one day, and the Department of Energy said, "Could you take $5 million more dollars?" That's what I said. And that's the problem. A lot of the stuff that's going on in universities today, the big bucks being poured into them, and this is where they're getting their money, and this is where they get their tenure and their fame and all this sort of thing from these big bucks that are being thrown at them. And I gave this similar talk like this at Columbia University back in 2013, I think. And I actually talked to people there who were looking at a project to do carbon sequestration, and I kind of had a thought that maybe their idea might work, but I'm very skeptical of that. Was basically that Saudi Arabia would become the CO2 sink of the world. They had this great Oman ophiolite that you could mineralize the carbon and you could pull it all out of the air there. You didn't have to do it at plants. You didn't have to locate it, co-locate with plants. You just pulled all this CO2 out of the atmosphere and did it for the globe. So I'm fairly skeptical.
So if I can,
Yeah, Dave.
So the second question is, okay, so we have these huge demands on mining and production of minerals, and we looked at EVs and we looked at conventional vehicles. What's your opinion about how we're going to be able to move forward in a sustainable way and control carbon?
I think sustainability is nonsense. I mean, we've way overreached the population, and there's just nothing about what we're doing that's sustainable. We're unsustainable the way the globe is right now. But in terms of maybe getting some help, I looked at oil and gas, and what occurred in oil and gas production in the United States. I mean, in 2007, you and Maury and I were at that ASPO convention. If you told anybody that we were going to produce more oil and gas domestically than were produced at our peak in 1970, I mean, people would have been laughed out of there. I mean, nobody would have given. I mean, if you even said we were going to turn the decline around, people wouldn't believe it. There was a guy there, one of the most astute observers that I know in my career, was willing to bet people that we were going to have $200 oil soon. It didn't happen. And it happened because of technology that nobody really anticipated. It wasn't any exotic technology. It was lots of different things that people learned how to do and do effectively. And it happened. And that gives me hope that we will learn the same thing, hopefully, relative to these alternative energies, that smart people are going to figure out some way to do it. Maybe it's going to be something like fusion. I just read the other day that fusion's back.
Yeah, fuel of the future and always will be.
That's right.
Thanks, Vince.
All right, that's all I can say.
Well, let's move on to John Culbertson. John, could you unmute and ask Vince your question? See if John's with us or not. We can't see him, but he has his hand up. Nothing from John. So, Bill, could you unmute and ask your question?
Right. Couple things that I've been seeing in the news lately that are interesting, and I just wanted Vince or someone else. By the way, thank you very much, Vince. A wonderful presentation. Really enjoyed it. A couple things that have been publicized. I think you might have some knowledge of some of the other attendees here about. One is the nodules in the Pacific. We used to call them manganese nodules a long time ago, but now the article was about how the U.S. has passed on trying to get into that business. Is that something that might contribute in some of the rare, what is it, cobalt? They had manganese, but not a lot, but I think there's copper and a few other critical ones. And that's one. And then the second one, a lot of publicity on the Salton Sea, where the hydrothermal people say they are able to extract a lot of lithium out of those hot water materials that they're drilling. And will that make any contribution into the lithium shortage?
Well, it'll make a contribution, but you saw in one of those charts that if we're going to do what we say we're going to do, we're going to need 45 times the lithium that's being used in 2020. I mean, we're going to need everything we can get there. As far as the manganese nodules go, that really bothers me. And again, it gets back to this population and what we're doing to this poor planet. They've shown in a lot of the fishing that's being done, they've got these huge nets now that they drag along the bottom and capture all these fish in, and these things have weights on them, and they're just destroying habitat on the bottom of the ocean for for the life. They're just wiping out. I mean, a lot of the creatures that live down there need little nooks and crannies, and we're going down and smooth them out. That's just from dragging a heavy fishing net. I mean, it's really heavy, tons. But now we're talking about going down and actually mining the seafloor. I mean, to me, what we're doing to the oceans, particularly with the plastics, is just, it's heartbreaking.
Sure.
We don't seem to care. I mean, obviously people care, but nobody who can do anything about it cares.
Right.
Right. Well, gee, I'll put in my 2 cents worth here. I want to give notice of a book called Volt Rush that covers the last 20 years or so, I'd say, of mineral exploitation around the world. The author takes you to Chile, to the Congo, to Australia and China as to where the minerals are coming from, and talks about the important characters and players, particularly the Chinese, as Vince has shown us, have dominated the processing end of it. And the reason they can dominate the processing is they got out early to dominate the acquisition of minerals from many of these countries. So this is an interesting story of what's going on now. It's as I said, it's full of the characters and the players and the drama of the mineral acquisition, mining and processing industries that are big players. Copper and cobalt and nickel and lithium are the 4 minerals that get a lot of play in this book. So there is a lot going on, and the questions that Vince has raised is, are we going to meet those huge increases in production of metals, and how will we do it? So that's my shot. Dave, did you have a final thing here? And Felicity also, go ahead.
On the theme of books, I wanted to pull this out earlier, but you just reminded me. So I wanted to call the attention of our participants to a book that I read. It's now 12 years old. It's called The Race for What's Left. And what's the subtitle? The Global Scramble for the World's Last Resources by Michael T. Clare, who's a university professor in Massachusetts. So he covers a lot of this stuff. I've had this book for quite some time. I bought it after I was running ASPO, the Association for the Study of Peak Oil, which is how I met Vince and Maury. But what Vince has put forth today is a much more current and germane analysis vis-a-vis the need for electric cars and decarbonization. So anyway, it's a very interesting book. I thought it was a good read. I buy a lot of used books, so you can probably get it for $5 someplace or a library. So anyway, thanks again, Vince, and thanks, Phil.
Okay, thank you. I guess one question from Felicity. Please unmute.
It's not a question, Phil. I was just gonna, I had been sending you some messages, and also I think Lucy Stolzenberg, an occasional member of our group here, had sent you a notice about a very recent series of programs that the public radio podcast called On Point did about, it was called Elements of Energy, Mining for a Green Future. Obviously, it is nowhere near the depth and the analysis that we got from Vince, but it's an interesting, it shows that there are a lot of people who are trying to address this issue, and it's I think each episode is about an hour. The first one is about lithium, second one about copper, third one about cobalt, and the fourth one about nickel. And then finally, there's an episode about can we meet our climate targets with these limitations. So it's very apropos. People might just enjoy listening to it, and especially because there might well be some things in it that are wrong that Vince could correct them on and get invited to a future episode of On Point and set everybody straight.
Well, I haven't figured these things out. I'm using the data from the International Energy Agency, which these countries pay to do this work, to provide them with the information. And I really put a lot of confidence in what I've seen that they do. And it's not anything new. I think they've been recognized, and I've initially looked at them as good resource on petroleum issues, since I spent 2 decades in the petroleum industry. And I've just found them to be quite reliable. The Energy Information Agency of our government is quite good about gathering information from the United States also. The problem I have with them is that their forecasts, I think, if I've followed them through the years, and they're just ludicrous. And I've talked with the people involved in them, and I think they pretty much acknowledge that also. Most forecasts are very difficult to see come to any kind of real fruition to what they've been saying. And I started back in the oil industry when the company that I worked for would make its price forecasts for oil and what it was going to be for the next 5. I mean, if you could do it for 5 years, that was all anybody paid any attention to. But they were so wrong. Year after year after year, they were always going to increase, except that the starting point was always lower than the year before. So the prices were going down for 4 and 5 years, but we were still predicting, it's going to be $100 a barrel by 1982. I used to even carry those around. I plotted all those forecasts on the same chart that showed how the starting point was always declining, just when people would say, well, we know what's going to happen. It's very, very difficult.
Okay, well, thank you, Vince. I'll stop the recording at this point. Oh, before I do that, I do want to say that Yogi Berra had a few comments about the future, which might be
Yes.
But I can't even predict the future into next week, because the speaker that we had for next week has had to cancel due to a family event. So stay tuned, and my prediction for the future will be out on Friday in terms of the speaker for next Monday. So thank you all for coming, and we will resume in a week from today, and see you then. Thanks again, Vince.
Thanks,
I very
Vince.
much appreciate you all coming.
Great stuff. Thank you.